If I want to print the result of calculation such as this, I can simply duplicate this system output statement in my method main that I have here and replace the second literal string with this expression, which uses the numbers to compute 2 plus 5 multiplied by 3. So if I run this code, you see that it prints 21. So the result of this is 21. Internally, when the class file containing the bytecode is generated for this program, computations like this and all the rest of the executable code looks like instructions. So for instance, here we really have to compute first what is happening inside parentheses and then multiplied by 3, because this is how parentheses or grouping directs real arithmetic rules to work. So here we would say multiply what? We would say multiply the result of 2 plus 5, so the instruction would be add 2 and 5, and then multiply the result of this, which is 7, by 3. And so multiply, then execute it later on. And what happens is that, of course, we also use print statement or print line here to print the result. So essentially you need to realize that expressions like this and all statements end up somewhere in the bytecode that looks more like this set of different commands with certain arguments or operands that these commands operate on. So of course the source code can have syntax errors, but when the syntax errors are all fixed, the bytecode should be pretty clean. So this code rarely has serious issues. It's very likely that our source code can have syntax errors and logical errors that we need to be able to fix before we make this code final. So most basic type of language that computer understands is the machine language or assembler, which is considered to be low-level programming language. And this low level is because all the machine code languages are platform specific. So if I want to write CPU instructions directly, I need to be able to find an assembler which will be able to understand and generate executable code directly on the computer that I'm running. So if I need to move that program to a different platform, there could be a different assembler. High-level programming languages are all portable, and the general expectation is that if we write this code in Java, it will run exactly the same on a Mac, on a Linux, or in Unix environment, or on Windows. So everything achieved by executing these statements, that a lot of them have semicolons at the end. So that's just general syntax rules. Logic errors could be also referred to as semantic errors. Are not syntax errors. They will not cause compiler to generate error messages. But for example, if I wanted to print this in a different order, for instance, I want to print 21 and then say hello world, then I would have to switch around these two statements. So that would be something that all the logical errors that basically yield incorrect result when you're executing your program have to be addressed by the programmer. So we already ran through a NetBeans demo, and we created our first project, and we talked about this specific code. Once again, the first console Java application that can print this text hello world, we already had it in place when we started with our project. So right here, this is an example of a literal string. It appears in output exactly as entered, of course, and you need to use double quotes to enclose these characters in double quotes. Program arguments could be information specified on the command line when you run it from the command line, and if you do, the command line arguments will appear as these arguments right here. So the main method of our application is where the execution of this Java program begins, and you can optionally have command line arguments passed to this main method. Method is synonymous to a procedure or function or a task, so it's normally designated to do something useful. And generally speaking, classes can have multiple methods, and the project can have multiple classes, and so the application keeps growing, but all of the code, all of the executable code pretty much is contained somewhere in some method. The system class is a placeholder for different system level devices and facilities. And out is an example of an output, a standard output stream, which is normally given to any program running on a computer. In our case, we use it to apply printline method that is built into it, and you can see that we can print strings, and we can also print the results of computations or values in our variables and so forth. So as we mentioned earlier, the syntax of our first Java program actually required this code to be placed inside the main method, but also beyond that, the entire main method is placed inside the scope of class name homework1. So everything that we do in Java programs, in our Java projects, has to be somewhere inside the Java file and has to belong to some sort of class. Class has a name, and or also known as identifier, and the allowable names can use letters, underscores, dollar signs, but cannot begin with a digit. So this right here would be not a correct name for the class. You can use digits somewhere here, right, but not at the beginning of the name of the class. So these are the general rules of identifiers, and highlighted parts of the source file are keywords. For instance, public, class, void, package right here are examples of keywords. In other words, reserved keywords by Java programming language. You cannot use these keywords to create your own names or identifiers. And so these are more examples of such reserved keywords. So it's pretty simple. The compiler will give you an error if you try to use something like void in place of the name of your class name. Comments are very important. There are two types of comments in Java. Something that can be used as a multi-line comment, begins with /* and ends with */. You can see that you can place multiple lines inside a comment like this. It's designed to contain paragraphs of information readable by humans and so forth. I also would like to take a note about multi-line comment, is that there is a convention that a multi-line comment that starts with not one but multiple, basically two asterisks, is designated as a Java doc comment. And there is another utility in Java environment which is called JavaDoc, which is able to find these types of comments in Java source files and be able to generate HTML documentation for these sources. So conventionally, if you're using multi-line comments, just use this format, and if you're using this format, it will be understood as JavaDoc comments. Another example of a comment would be a line comment. A line comment would look like this. It starts with 2 forward slashes and then follows by whatever comment you would like to add. For example, our first program. Right? So this is a comment, and this is a line comment. It begins with 2 forward slashes and ends at the end of this line. Multi-line comments are also called block comments. And this is just another slide that shows you that programs can be built outside of this IDE environment on the command line. So you could design your programs just using very simple editor and invoke compiler, but you need to know exactly configuration of your Java development kit, the version of Java that you're using here. So we're not going to be covering any of this here. I'm just giving you some ideas that everything we do inside IDE can also be done on the command line. For example, I can go back to our project, do a clean build, and then display the output window, and it gives me examples of some of the command lines that I could execute. To give you a quick demonstration, I can open the command line. This is the version of the Java compiler that I am using, the entire JDK, Java Development Kit. I will copy this and paste it in here, but because it includes spaces, I will use quotes around this path to Java utility, specify -jar, which will direct Java runtime to unpack the application from the Java archive, and this is the location of the Java archive that was built for us. So I add this to my command line. So this is now the entire command line that I'm using here, and you see that if I execute it, this does exactly the same as if I was running it inside the IDE, inside NetBeans. Sometimes it's useful to be able to debug programs outside of this environment. So there you go. There is always a way to use the command line with Java.